Now, we continue the flip-flops lecture, and what we have for the sequential circuit. We have some examples and some review. As I tell you, the review part you will read yourself. No problem. Example part I will solve, and after that we have the final state or state diagram concept. Then for the first half, we have 8 examples which we will solve, and next part we have the state diagram. Okay? Please be active, have the paper. If you don't solve it, you will not understand. First of all, I have the circuit. Which in that they give me the sequence of time and inputs. Okay? This example is very nice. What it said. It said that assume that we have some inverter in the network below which has the propagation delay of 5. Propagation delay means that the time that you need to change your state from level or edge. Okay? And the AND gate has a propagation delay of 10 nanoseconds. What they want that draw the timing diagram for the network which shows X, Y, Z. And assuming X is initially 0, Y is initially 1, X become 1 for 18 nanoseconds, and X is 0 again. Let us see. First of all, what is Z?
No, feedback.
I know. What is the equation for the Z?
X. Not X and Y. Oh.
X multiplied by Y. Y bar. And not just like that. It should be plus. Is it Z or no?
Y bar.
Why no answer? Y bar.
Is Y not?
What is the output? Why it's become Y bar? It's not Y bar. It's XY.
Yeah. Okay. Because first is Y, then it will come again.
Okay? It can be like this, or it can be X Z prime. Any of these two. Okay? Now I will give you the timing diagram. See the timing diagram. Can you draw it? What could be the Z? Hurry up. Read the question once more. He said that sometimes we will give this timing diagram, sometimes we will not give. Because this is the first example that we want to solve. I want to give here for that. Okay? One thing. X is initially
0.
Y is initially
1.
Then what we have? X become 1 for 18 nanoseconds. 10, 20, 13, 14, 15, 16, 17, 18. Up to this much we are 1. Okay? And then X become 0 again.
9.
Now draw it. If it will be 10 and I become for 18 nanoseconds, then up to 19 I should be 1. What about Y? Y also they give. We have the pattern. Y is 1. But see the time. Up to 20 we are 1. Then we become down. Till what time we are down? 40. Till 40. Then when again we come up? Up to 40. Yes or no? Yes. Now calculate. I have the formula. I know that Z is xy. Okay. Now we can calculate. 0. What is the answer? 0. Up to this. Next pulse. 1 and 1. It should up. Another one. Next pulse. 0. We are between. No. We cannot put between. This is the point that we should say that we are sensitive to the level or we are sensitive to the edge. Means that we are flip-flops or we are latch. Okay, tell me. Next one. 0 and 1. Here. 1 and 1. Here again. Latch or flip-flops. Means that level or edge. Again. This one, okay. This one, okay. This one again we have problem. Let us see. The output is like this. 0 and 1 is 0. 1 and 1 is 0. What does it mean? I sensitive to the edge or I sensitive to the level? And where is my pulse? Edge? How we say edge? Can you imagine the pulse here? Initially, when we will put, we can do something like this. Throw the pulse for yourself, throw it. If you learn this, then for a state diagram, we don't have much more problem. Draw the X and Y. After that, draw the clock pulse. Main thing that you should remember here is the amount of delay that you have. Okay. Means that based on some delay part, and acting of delay, some propagation of the delay, the output will be changed. Maybe for first example, it's a little bit difficult for you, but you will understand better. Okay? The main thing is that even if we forget the delay, just we think for this as the output, we just need the timing diagram. Based on this timing diagram, in each sequence we can calculate. Now, 1 and 1 is 0. How? Because we have delay. Okay, we have some delay. This one wants to come here, but there is some propagation delay, which will kick the pulse to the next step. Pulse wants to become 1, but it will take some delay, and after that it will happen. Okay, you will see here. Again, Next pass. 1 and 1. It's 1. Okay? We come in here. 0 and 1. Should be 0. But with some delay. Okay? Next one. 1 and 1. It's coming 1. But with some delay. 0 and 1. Once to become 0. But with some delay. Do you know in what when this propagation delay is something like person who will push? Okay. If we say that the propagation delay is 0, you don't have any delay. Okay, you can simply put this Z, and after that add the amount of the time that we need for propagation delay. Instead, we will just push the signal as the delay. Okay. That was the first trial. Now do for this. Now, I have one flip-flops, SR flip-flops. This is my inputs. I want that to show that Q, and this is Q bar, but we call it P. Okay. Initial state for Q is 0. Initial state, then if it's 0, it should be 1. Now draw it, please. Now, what is the Q? Q is 0. No, the formula, first of all, Q is 1. S bar R Q. Is it okay? Any problem? We are going to solve. See one by one, okay? Here. S R. First one, okay? Don't think for this part. This part is some propagation delay. Some delay which regularly we have, naturally we have, but we don't consider it, okay? 1. I will put in formula. Sy is 0. 1 multiplied by 0. What it should be? It should be 0. Then it's okay. But really it will not stop from next part. We have some delay, then that part will happen. Okay. How much is this delay? It's depend on the IC that you use. They specify the. But anyway, we are going to think ideally. Okay. Some delay, some delta delay. Next part. 0. It's become 1. Then RQ. Q is now 1. But previous Q is still 0. Now it's become 1. Okay? Now the next Q is 1. Okay? Now we will see. It's become 0, nothing. 1 multiplied by Q. What is that? It's become 1. Okay? So again we are not tuned here. Some delay we have. As I said, some person push, some person kick the wave. How much? This much. Why this much? Because we have propagation delay. Next part. 0 and 1. What is my Q? My Q is 1. Now continue. It's become 0. It's become 1 multiplied by 1. No, 0 multiplied by 1. It's become 0. But not exactly Q. We tell you. Next part. 1. It's become 0 plus 1 multiplied 0. It's 0. Then next one. This 0, 1 multiplied 0. How much is that? 0. Then next. 0 is become 1. 0 multiplied by 0 is become 0. Then output is 1. Got it?
Yes, sir.
Now, what would be the Q bar? Q bar is whatever we have here
Is
opposite. Now you will see. Simply we can draw the Q bar here. Most of them they say that when this is 0, this is 1. Then when this is 1, we are 0. When this is 0, we are 1. Here, what will happen then?
There is delay.
We have some delay for that. Some wordsmith also I have done here. As you remember, what was my formula? My formula was S prime. Okay? We can also calculate like this. Means that we can draw the S prime. Draw the S prime and then do that. That is one method. Another method is that we can calculate it directly from the way. S prime, R prime, Q prime, like that, and just put it in the formula. That is also one method. What is what I said?
Yes, sir.
One is that we can predict exactly from the graph. Another one is that they will put S prime and R prime, then just in this. How much is that? Put it. Did you understand this?
Yes, sir.
So, if we predict, we don't need to put in S prime.
Yes, no need to put this prime. That is why I have hidden it at the first time. But I tell you that why we put it there. And how much is that delay that we discussed? Is this? Delta T. Okay? Sometimes in the exam they said that remove the propagation related that don't consider it. Sometimes they say that consider it as suppose 5 nanoseconds, 10 nanoseconds. Then you should draw it based on these delay nanosecond. I will try to solve much more based on this delay later. Okay? Yeah. Okay, who will help me? We are in the flip-flops. Flip-flops are triggered with the edge. Means that I should just see through this edge. Okay? Edge number 1. R is 0. S is 0. 0. 0, 0. Q is also 0. Let us see. R is no. Here I will not do anything since the next 3. Then they give us, I think, yes. This part they give us. What I will see here. Okay. Here, this is 0, this is 1. Put in formula. It's become 1, it's become 1, multiply 0. It should be
0. It's 1.
It should be 1. Then again I will not see. Means that I will continue here. Okay. Here what is my status? 1, 0. And previous time I was 1. Okay. 1, 0, 1. It should be 1. Again I will not see. Till here. Because I will continue the line. Till here. 0, 1, 0, 1, 1. Should be 1. Let us see what is the output. Yes. We will draw it very badly, but anyway. Because this line is here. This line is also here. Then we will see 0, 0, 0 before that, this becomes 0, and like this. We are sensing through the which one? Rising edge. Understand? Yes or no? Next. How we can make the T flip-flop from J flip-flop? Can you tell me the formula for the T flip-flops?
Absolutely.
T flip-flops was Q XOR with T. What was Q XOR with T? Means that Q bar, T. Agree?
Yes, sir.
What is the formula for the J card flip-flops? J card. K bar Q J Q bar. Okay or no? Now you tell me, how many conditions we have for T flip-flops? For T we just have 0,
No, 1.
0 or 1.
Yeah, 2.
What we want the box which is inside is J card, and what we will look at it with the function of T. Okay? Something like this. This is what we thought. And directly when I teach you the T flip-flops and T flip-flops, I tell you how to make from J card. Okay? If I want to make the D flip-flop, next example, just I should put the hand here. And for T flip-flops, I should just connect J and K together. Then, if J and K together connect, means that I have just two cases. One is that both of them are 0. One is that both of them are 1. And in the T flip-flops is like that. I have Q, and when I have 1, I have Q bar. Okay? We review two examples. Third one is more important. You will see. But we will see this. Here I made T flip-flop from J card. What about D flip-flops? What is the formula?
No, let's put a not.
No. First tell me the formula for D flip-flops.
D is equal to Q.
D is equal, Q bar is equal to Q T plus 1. Yes or no? What here we said? We said that we have the same formula for E and J cup. But the difference is that if I want to make the J cup, I should put the not here. We consider that, okay? Means that if my J is 0, K should be 1. And if J is 1, K should be
0.
Understand that? That was the two review things that we have done. Okay? Now, the main part. If I want to make the J card flip-flop from T, how I should? I do the T from J card. Now, vice versa. JK from T. What should I do? We should draw the table. Okay? In the table, what we have? We have one color J, K. And this is my T, and this is my Q. Actually, this is not Q. This is Q plus 1 or Q T plus 1. Q positive. How many conditions I have for 3 bits?
8.
8. Don't forget. 1, 2, 4. 6. 4. Okay. Now what is my output? my output. When J and K is 0, what is the output for JK?
0.
Put the formula JK. K bar Q plus JQ bar.
0.
What is you can call sorry, this is Q, this is the pillar. Okay? Put in formula. K bar is 1, 0, plus 0, 1.
0.
It's become
0.
0.
Yeah.
Second one, put it in formula. This is 0, this is 1. Okay?
0.
Now put K is 1, 0, K is 0. What is output? 0. E is 0. Agree? Next. Next one. Q is 0. Okay? Q is still 0. What is J? J is 1.
K is 0, J is 1.
K is also 1. This is 0. Answer is what?
1.
1. Next. Calculate. Area.
Next one also on.
0, 1.
Next one also on.
1. Next one. Don't see the table. Calculate. Next one is 0. It should be 0. It should be 1. It should be 0 and 1. This is for the T or for the Q, T plus 1. What I will do now, what actually we are searching for the relation between JK flip-flops and T flip-flops. Okay? This is QJK. Now, if I want to make the T from them, or I want to make the JK from T, what should be the formula to convert them? That is what we are searching. We are going to put the case which was 1, okay, and calculate the T1. See, one of the cases Q is 0 and JK is 1, 1. 0 and 1. This is 1. Okay. Another case is that we have Q is 1 and this is 0, 1. Okay. Another case is that all are 1. Okay. If I put into the corner map like this, what is the common part here? No, 1, 1 means that JK. JK. Okay. Here, what is the common part? K. K and Q. Q.
Yeah.
K.
J.
Agree? I have some option. One is that I can put the loops here, and one more here, or I can have two separate loops. I put two separate loops. First one is that the common part here is Q, and at the top is J. Q and J. Okay? Q bar and J. And here, what is the common part? Q and K. Then we can memorize another formula. Another formula is this: J Q bar plus K Q. Now, how I should make? I should make very simple. The code is T. Okay. What I want the JQT and KQT. Means that one feedback from Q and one feedback from Q bar. Okay, like that. It will come. Why I put just like this? Because in the sequential circuit, we are just using NAND and OR. When we want to make the sequential circuit, we just making and OR. Okay, then simply we will do it. And mainly we have this part. Just we should know the relation. Here is OR. Okay. We need the AND JK. J should be AND with Q bar, and K should be AND with Q. Yes? Both of them should be OR, and then injected into T. Understand that? Yes?
Yes, sir.
One question. How we can make a JK from D field? Assignment. Take one piece of paper and write this point for you. Have it. It's very nice. You should memorize this code. Okay?
KQ or KQ?
K bar Q, Q bar J. Or JQ bar.
That's what the first one.
First one it can be 2. It can be
No.
S plus R bar Q bar. Something that we saw. It depends on the NAND gate or no.
For T.
For T is Q X for T.
It goes to J plus K bar Q.
This is two different formulas.
Yeah. Makeable.
This is making
The other formula is JQ bar plus KQ or K bar Q.
KQ. This is how we make the JK from T. Rest of them are how we make them from JK. It's something like this. Make from JK.